Hello.
Hello.
We have a new guest, and again, another day we are streaming across APAC. So amazing.
Yes, APAC.
How are you, Zach? How are you, Jatin?
So it's been a busy week for me. Very busy week.
Same
so
here.
many things to end up, reviews. In Japan, we have something called as new graduation ceremony on 1st April. Not a April Fool's Day, but 1st April is the new graduation ceremony day. So all the people here were busy. Pretty busy week. All right.
Yeah, same here with us because April 1st means our new financial year starting. So yeah, it's been a very, very busy week, but yeah, it's cool. Weekend was really good. Ready for tomorrow, Sunday.
Nice. Yeah. April Fool's Day and the financial year kicks off on the same day. So hope we're not getting fooled.
I feel sad for the new graduates in Japan. Okay. So
well, we have a regular attendee or joinee who's always joining us, Bhavesh, and he also says hi to you, Jatin. So hi, Bhavesh.
Hi, Bhavesh. Actually, I was in Bhavesh. Me and Bhavesh was in cohort in our new voices cohort from AWS. So it was an amazing time with Bhavesh there. Very supportive guy. Very, very amazing guy.
Okay, so we're going to see something that you learned off the new voices in action today.
Yeah, maybe. Oh, no. We're not doing that.
I'm putting you on the spot.
Yeah, I already sent the link to Mark. Mark might be watching it. Just kidding.
All right. Yeah.
Awesome. So, before we get into the topic, Zach has always been talking about EKS and EKS Auto Mode, and we did talk about EKS Auto Mode when it was launched. And Zach, you want to talk about it? I know you're on your toes.
Yeah. I can talk about EKS daily because Jatin, I think we already had a good chat in Community Builder Slack channel, right? So yes, EKS is something like day-to-day I work with. Because I'm on a platform team, mainly taking care of the EKS platform, right? So when Amazon announced the EKS Auto Mode, I think I would be the one of the first person to get excited. And I think I wrote a blog article, and Jatin, you and myself, right? We were troubleshooting something with the code pipeline release, and we found some issues, and we get the feedback, and it was really good. And we both learning, and I remember I was in the airport and I was messaging Jatin, okay, hey dude, I'm flying, I'll reply to back later, and finally we made it. It's so good, cool. So yeah, if you want to talk, Jones, it's a bad idea because I will take the entire day.
Yeah, I'll cut you off.
Yeah.
Awesome. Yeah. In case if you missed the EKS series that we hosted on our podcast, it's there in the chat. You can check out all the things that we spoke about. You can actually see Zach in action, and we talked a lot.
Yeah. And I want to inform something. So one of the session we did, Jatin, you aware, right? The code pipeline thing, where you can now directly deploy to your EKS clusters. So in the demo, I was using the code build to build the content image.
Right. We don't
I wasn't aware that we don't have to do that because you have the ECR build already, and it was amazing. And Jatin also was like sending me a lot of links and helped me a lot. And I I updated my blog article and informed everyone, okay, you don't have to go through that pain anymore, and you can directly just use these the task and just build it and push it to the ECR. So that is something I wanted to inform the rest of the audiences.
Wow. Yeah, this is literally community in action.
I mean, one of the things which I'm very excited, like lately, code pipeline, the full code pipeline stack is like on steroids. I mean, you do anything, it's there. It's getting like all the good things like building command execution, building images, deployments now directly to EKS. Recently, now you can copy your ECR images to different regions. Like one can be a central ECR repo, and you can post it to different regions, different accounts as well. Crazy updates coming up with code pipeline stack. So I'm like pretty excited for that.
Well, talking about build and everything, Jatin, what are we talking about today?
Okay, first things first. I will teach you some guys. Since I'm living in Tokyo right now, I'll teach you some little bit very basic Japanese. So we are gonna say konnichiwa. Konnichiwa is like hey. So
Konnichiwa.
minasan. Minasan is like everyone, whoever is here right now. So konnichiwa minasan.
Konnichiwa.
Konnichiwa minasan.
Yeah, that's something which everybody will be starting with that. And in the end, I'll also give you something more. But for now, let's have it like konnichiwa minasan. I would like to share my screen. Yeah, it's on shared screen. Yeah.
Yep.
So today we are talking about a very interesting topic which I've been working in my organization, something called as self-hosted runners, GitHub. Idea is that CI/CD pipelines, as you scale up your organization, scale up your products, scale up your development, gets slower and slower. So the idea here is today how to make it faster without less operational management. Can this solution be effective in terms of cost? So we are talking about two ideas: making CI/CD pipeline faster, less management, and better cost. But on what? EKS Auto. To take away that operational management, EKS Auto. Yeah. I mean, Zach would be excited. I don't know about you. Jones. So
Yes.
okay. Let me just bring it to the slideshow version. Okay. So like I said, we are going to run our self-hosted runners on EKS Auto. Just to give you one idea behind why I did, running your CI/CD pipelines on an average GitHub, default runners is slow. You don't have that compute. And if you're going for hosted runners, like the bigger runners from GitHub, you need one team plans, which you have to pay again. You don't have any control how it's gonna work. You also have to pay storage cost. You also have to pay extra cost for concurrent jobs because there are certain limitations when you run your workflows on GitHub large hosted runners. There will be a lot of mumbling and jumbling of terms because these are very similar terms. So please excuse me and point me out if I fumble with some words. Okay. Oh wait. Future Jatin just said that I have to deploy some Terraform code. So as an idea, I am going to do is very real time. I'm going to deploy some Terraform resources, the entire tech stack for this. It should work because demos fail, but let's see how it works.
May the demo gods be with you.
Okay, let's just deploy Terraform apply. The entire solution over here. Oh, by the way, we are going to use Oh, see, things happen. But I just AWS login profile, AWS test admin. Just give me 1 second. Okay, that's gonna book. Admin. It just takes like 15-20 seconds. Yeah, and we are done. So just for the record for the audience, we don't have any clusters. It's US East 1, account ID 6962, fine. But we don't have anything. Now let me just Terraform apply. Okay. I don't want to do auto approve, but just in case. 72 resources. Yes.
72 resources.
Yeah. I mean, 10 minutes for EKS cluster. That's why I'm just starting away with the deployments. Otherwise, yeah, EKS Auto doesn't take so many resources. It's just the GitHub resources, this self-hosted runners resources, and some Karpenter node tools, custom resources, which we are going to use. But anyways, let's just jump back to our presentation. Meanwhile, it's happening. Okay, so first thing first, whoever don't know in our audience pool, I think Zacs knows me somehow. It's a little bit contribution towards AWS, that's why they know me. But I'm just a curious builder who loves building solutions around AWS, Kubernetes, CI/CD, and now generative AI. Have been doing things around generative AI. So just loving this journey. I've been a community builder for now like 3 years, and have been very amazing. Learning from these guys, AWS heroes. Very amazing part of the journey. So whoever is watching this, and if you want to upskill your career, whether it's in cloud or in general, join AWS CB. Have some contribution, and you will see how it helps your career. So, okay, for today's session, what are we gonna do with, like, we're just gonna see in brief what's the self-hosted runners all about, how to set up on your EKS Auto, the self-hosted runners on your EKS Auto. We should see in action as well, and some cost comparison with GitHub large hosted runners and this EKS Auto self-hosted runners. This is gonna be 4 takeaways, but we should have an end game. The end game would be, which I want to discuss with Zacs, especially Arshad. EKS Auto for self-hosted runners is it cheaper, better? That's what we just have to dive into. All right. So, why did I choose this topic? 1, speed and control. GitHub Actions, like I said earlier, these are slow. Default are slow. If you go for larger runners, these are okay. These good performance, but concurrent jobs, no, it doesn't work like that. You have to, you are coming up into some limitations. At this moment, GitHub Teams and GitHub Enterprise plans goes for 1,000 concurrent executions only. If you want to upskill that for a larger organization, you have to request customer and pay something. You don't have any control. I mean, where your data is going, how is it going, you have no control on that. Performance, like when you just deep dive into concurrent jobs, and I'm expecting, like, we are talking about this solution for a very large organization having a very good scale, which have running a lot of teams, a lot of developers are running concurrently all the kind of GitHub Actions workflows, and at that time performance gets really bad. Expensive. It is expensive. GitHub runners, like, for this solution, we are trying to compare 8-core runners, which is like 8-core vCPUs with 32 GB RAM. Same on EKS Auto and same on GitHub Actions. It costs, GitHub Actions just costs per minute charges $0.32 for 8-core larger hosted runners. So yeah, that's why I'm choosing this topic for 3 reasons. Let's talk about first takeaway, components of self-hosted runners. Because if you understand this concept, Now you can develop the solution, whether it's EKS Auto or AKS Automatic or your um, proprietary Kubernetes cluster which you're running on your bare metals. There are three things which are components of this arc, listener, and runner set. This could be an architecture, how it works, but so the simple flow is, this is provided by GitHub, but I think in a very simple terms, I would just say, forget about all those numbers which are happening. It's gonna confuse you. There's a workflow on the left-hand side, simple ci.yaml. When you run it, the custom self-hosted runners will talk to your something called as control manager, which is Arc running deployed in your cluster. They're going to talk, authenticate. Then the control goes to runner scale set listener, which does this kind of decision making based on the number of workflows which are happening right now. It's gonna scale your runner pods. So your execution happens on the extreme right of the architecture, which is runner A, B, C. So runner A will be running workflow, runner B workflow, runner C. So this runner scale set listener pod is actually making the decision how much to scale. 5, 10, 15. You can set minimum, you can set maximum. Minimum means at all times, one, like if you have set minimum equals to 1, at all times, one runner pod will be running in your cluster. If you have set maximum, which means if somebody gets notorious, only that much only workflows can be run at that kind of. So you have all control over here. And the good thing is this manager listener is all configurable. GitHub Actions have provided you this Helm charts which you can configure. So all the control here configurable. You can configure certificates, proxies, say whatnot. In very simple terms, this is the flow which is going to happen. And yeah, just for technical details, like I said, Arc is Actions Runner Controller, short for the figure form. It is like a manager managing the state, like whatever you say about the desired configuration, Arc controller will be managing the state, ensuring the configuration stays, usual controller definition of a Kubernetes. There's another component, listener, like I said, managing decisions of scaling of runners. One thing should understand is one listener per runner scale set. What does this mean? You can have multiple runner scale sets, for different kinds of job. For example, if your job is like running front-end test, can go to front-end runner scale set. If you have to test backend with some different configuration, can go to different backend runner scale set. Your configurations, your power. Listener. There's also one function of listener. Listener talks back to GitHub backend, all that thing. Runner scale set, where we usually play around as a consumer. Think of this as a grouping of all these runner sets, self-hosted runners grouping. So runner scale set will group one kind of runner sets. They can have multiple runner sets, like I said, minimum and max concepts. If you want to run runners, if you want to say, I want to run backend runner, this job on backend runner, these are addressable by names. So you just mention your names in your GitHub workflows and voila, it works. A simple process which is happening, you run a job, you give an address name, that job workflows GitHub Actions gets queued up and gets assigned to this runner scale set. Then that runner scale set talks to Arc, and once Arc says, okay, you can do that, it tries to scale up. When it tries to scale up, it's going to create new runner pod where your actual workflow will run, and it gets registered with GitHub. And that's when the runner is created, you get final execution. So this is the final step which I
have a question. Sorry, if you go back to the previous slide. Yes. So which you mean the slide deck?
Okay.
So you're saying me like it supports zero scaling.
Yes.
Like
actually, right. We are at zero scaling.
That's the point. Nice.
Yes.
Now I can understand where you're going now.
Exactly. So now you will understand. Like, Arshad, let's
Yes.
not. Yeah. No spoiler alerts, but we'll give you.
Okay. Now I understand. Okay, cool. Go ahead.
Yeah. Jones, did you understand like how it's going on?
Yep.
Because you are very important for me as a non-Kubernetes guy. You are more important for me.
He's a Kubernetes guy now.
Good. If there's any question, please stop me. Okay. There are two things which are very special about this self-hosted runners. Actually, two modes. There's one container mode, and another mode is Kubernetes mode in the next slide. So when we are running GitHub Actions or any CI/CD actions, we are trying to build Docker images. We are testing different container services as services and testing things. Like, for example, a backend test can have one service talking to another, and that's how we do testing, right? Usual. When we are doing this self-hosted runners, we are actually running it inside Kubernetes cluster. So we are already using a container for self-hosted runners, which also means we cannot use Docker inside another container by default. So there's this concept called Docker inside Docker, DIND. If you go into details, it's gonna get complex, but good thing is the GitHub team has provided you images for DIND, short form for Docker inside Docker. And that's where it supports you to run this kind of jobs like testing container as services. One thing you have to note, building Docker images is not possible in this mode. That's a limitation. Why there's a Kubernetes mode? There's also another mode called Kubernetes mode. Because since this Docker inside Docker will be running in a privileged mode, which means because it has to talk to Docker socket, daemon socket, so it has to run in a privileged mode. But I can understand some organizations doesn't get really comfortable running Docker as a privileged mode, so they have introduced Kubernetes mode, which when you can't use privileged mode, use this mode. Power is yours. So today we're going to see the normal runners like GitHub runners and DIND mode, which I have configured. Kubernetes mode is very simple. You just have to do some configurations, which I will tell you in the walkthrough of the code. But that's all about theory part. Any questions on the concepts from the conceptual part?
Docker inside Docker. That's new for me.
Yes, it was new for me also, and
I have been through that pain. Docker in Docker. What is the tool name? It's starting with K, right? I forgot it. Like
Killian.
Sorry?
Killian or something. Canonical Killian, something like that.
Yeah.
Something. Even I'm also not good with that name, but yeah. Okay. So let's go to second takeaway. How to set up EKS Auto for self-hosted runners. Just in case, before second takeaway, Jones, if you want to share the link for this GitHub documentation, you can do that in the chat. All right. How to set up your EKS Auto for self-hosted runners. Now, here we are going to talk about the code walkthrough. But before that, let me just check. Okay, things are doing pretty good for still. We can do something. We can take some time. Okay. So I didn't create a very good architecture, but this is the simple architecture if you want to see.
Simplicity, Jatin, simplicity.
Yeah, exactly. I just started loving Excalibur for that. Okay. We have a GitHub. There's a user on the left-hand side over here. The user is going to trigger run a workflow, trigger a workflow. That workflow is going to talk to our AWS account, VPC, EKS Auto right now. And inside EKS Auto, behind the scenes, there is something called Karpenter. I'm pretty sure a lot of people who are the regular audience might be knowing from this channel. But just in case, EKS Auto is a new offering from AWS, running Karpenter for you, managing entire everything for you. So we are utilizing Karpenter for auto scaling of these runners. Let me tell you how it happens. let's break through more. So workflow says to EKS Auto, you need to run a runner, this kind of a GHA runner. This GHA runner needs some compute. Where it's gonna run? It's gonna run on your EC2 machine. Who's gonna provision EC2? Karpenter will provision EC2. Now, let's say you provision one workflow, one time EC2 comes. What if another user says, I want to run another workflow, but this job is still running on the right-hand side? So Karpenter is very smart enough that, okay, this EC2, which is where GHA runner is running right now, doesn't have space. I'm going to scale and provision new EC2 and run GHA runner on another one, another EC2, second EC2. And it goes like that, so on. And when the runners are, GHA runners completes its job, Karpenter is smart enough. There is consolidation policies, some policies to take away that EC2. Voila, you don't pay anything more than that. To be more cost effective, EKS Auto supports spot instances, which are very cheap. And now this is where I'm coming from the cost perspective. Since we are using spot instances and GitHub Actions can be run again and again, even if AWS says we want to take your spot instances, you can still run your GitHub Actions again. So this is going to be a very sort of a scalable solution and cost-effective solution using EKS Auto. For this solution, we are going to use M7 instances, M7 type instances, more specifically M7A2X large spot instances. It has a configuration of 8 core CPUs, 32 GB RAM. We are trying to simulate 8 core GitHub large hosted runners, just for the cost comparison and anything. You can choose 16, you can choose 32, you can choose 64, depending on your workload needs. All right. So before that, I'm going to do a walkthrough of the code and hopefully wow, it worked. It worked. The deployment is successful. And just to check some certain things. So when we deploy the solution, okay, I'll just show you one thing on the screen, then I will walk through. Cubans, I use Cubans Arc runners because I don't remember anything. Cubans Arc systems. I will tell you what is happening here. Just 1 minute, because it's easy to explain like that. Yeah. Okay, let's give you a walkthrough of the code very fast. We have an EKS Auto configuration. I'm only using node pools as system node pools. There's a purpose for that. I'm not using general purpose node pool because it doesn't allow you to configure. There's only MCR kind of instances, but here we need customization. So in the next step, I'll be showing how Karpenter EKS Auto allows you to have a custom node pools where you can define your kind of instances, what kind of instances you need, what kind of configuration you need, so on. Why are we using system node pools? Because GitHub, this is for if you were concentrating on the theory part, GitHub self-hosted runners will deploy 2 resources, controllers and runner scale set. So for those kind of 2 pods, controllers and listener pod, we need reliable nodes. We don't need nodes which gets disrupted and come again. So that is why we are using node pool system node pool, so that it stays persistent. That is the reason we are using system node pool. So this is the code for EKS. It's pretty same. We are using EKS module for this. And yeah, I'm going to tell you something here. For Arc, GitHub Action Arc controllers, we are using an Arc system namespace. GitHub wants you to use this namespace, Arc systems. Here your controllers will come. And here your controller will come, as well as your listener pod will be deployed over here. Arc runners namespace, you need Arc runners namespace where your runners will be deployed. Runners, which again, reiterating, where your GitHub Actions will be executed. So different namespaces, one for controllers and one for running your runners. That's it. Okay, let's go to Arc controllers. Here we are using an Arc controller. Like I said, chart is already provided, and we are using some controller values. Helm chart, we are configuring that. Why I need this configuration for controller? In the very simple terms, I am giving controller values. Just a minute. This is also provided by GitHub on the same link which Jones have shared with
So
you.
you're basically deploying the Helm chart of the arc,
Ah,
the
exactly.
resources, and passing the values. Okay.
Yes, but I have configured it in a different way. So let me just give you one more thing. So this system node pool has a taints, some tolerations, which is called as critical add-ons only. In order to deploy this controller on this system node pool, you need to have a toleration. That's why we need to configure this using this controller values so that it can be deployed. And we need to do the same for listener as well. Here is the listener configuration, which we are doing here as well. This is the Arc runner set for running normal GitHub workflows. I'm configuring it over here, and the same kind of configurations. Same. Oh, just a minute. Yeah. Here is the listener pods configuration, adding the same taints. Now, there's one more thing which I want to configure over here is that you said that we want to utilize 8 core vCPU. We are utilizing 8 core vCPUs. But you need to tell your runner pods. Right now, this configuration for listener pods, but you need to tell your runner pods how much memory, how much vCPU you can take. And GitHub Actions in the Helm chart also allows you to do that over here. So right now I'm requesting 4 vCPUs, 16, the limits are 8 and 32 GB. There's also a very interesting configuration, which is very important to note over here for all the audience, that we are going to use spot instances. So we need to tell our Arc controller that we want to use node pool of M7A spot, something called as M7A spot, and capacity type is going to be spot. So this node selector configuration will tell EKS that this is going to use M7A spot node pool, and capacity type will be spot instance for this kind of runner pods. The curious audience will be saying, hey, what is this M7A spot, right? You haven't mentioned anything about it. Now here's the concept over here. The third concept, I'm totally sure this is the last concept, which we say custom node pool. In EKS Auto, you can customize what kind of instances you need, what kind of configuration you need over in EKS Auto. That's what I'm just doing. I'm just configuring an M7A spot node class and node pool so that in very simple time, my runners will execute on M7A instances of type spot. That's it. I'll be sharing this code later after in a blog, so you can also use that. But that's all for this code. There's nothing more which we're saying. And just for the curiosity, we are also having a node pool YAML file which looks like that. So honestly, AWS has provided that. The point I'm trying to make here is you don't need to know Karpenter. Just use this configuration. AWS has provided that. Even a very non-Karpenter user can see, okay, I need an instance category of M type, instance family M7A, instance CPU 8, zone can be UST1, 1B, architecture AMD, and what kind of instances I need, spot instances. So right now in this configuration, you're trying to tell what kind of instances I need to request from EKS Auto, or EKS Auto, what kind of instances it should need, what kind of instances it should require. You can play with it as per your needs and requirements. Very simple. There's also a concept of called class. Class tells you where your instances, in very simple terms, the class will be telling you what kind of role it will take, what kind of security group your instances will take, subnets it will belong to, and what kind of ephemeral storage, something you want to configure on the fly. Trust me, when I say I don't know Karpenter at all, I haven't used Karpenter at all, but all I just did it is a copy paste and just use everyday language to understand, okay, this is how I can do that. That's it. That is why EKS Auto is a very good solution for this, because everything is being done on for you. Okay, so I have covered all the concepts. I know I should have done it in modules, but okay, doesn't matter. There's one more thing. I told you that we can have more than one kind of runner. So today I will show you that we can run, this will be an Arc runner set for one kind of jobs, and there is DIND, Docker and Docker, for another sort of jobs. Very important part is that no, we don't care about anything else, but we only care about these names, Arc runner set.
So these are already provided by GitHub, these Helm charts, publicly available.
Yes. In fact,
so we have to just configure the values and just deploy it.
That's it. There might be cases where you want to customize these Docker images, which is running behind this Helm chart. You can also do that. No problem with that.
Cool.
It's pretty good. Okay, I just found a typo, and I think that's gonna disturb me. But we'll figure it out later. No worries. Two important things we have to take from here. Your workflows depends on this name, Arc runner set DD in this case. Because this is how your GitHub will know where to send your workflows, which runners to send your workflows. Usually use Ubuntu latest for GitHub Actions normally by default, but if you want to use custom, you have to remember these names. This is how you will configuring your workflows to run. That's it. I mean, we don't have anything else. That's it. Yeah, that's all about this code. And yes, so when the configuration is correct and everything is correct, in your Arc systems namespace of your Kubernetes cluster, you will see a controller pod running. You will see a runner set with an extension of listener, which is a listener pod. The number of runner sets you have, the number of runner set listener pod you will have. Right now we have 2 runner sets, normal one and a DIND. So we have 2 runner sets. That's it.
How many nodes are running at the moment? Can we just curious.
Of course.
Can you do kubectl get nodes, a simple command?
I mean,
just one node, right? Yeah.
The system node pool.
So these are the system node pool. Okay, cool.
Yeah, only for hosting our controllers and listener pods. 3 pods.
Nice. So if you can type kubectl get node pools, maybe you can show whatever you node pools. Oh, sorry.
Yeah, we can do that.
Nice.
Simple.
And if you get the kubectl get node pools.
Node pools, yeah. So node pool.
So you can see like whatever the configuration was showing, right? The system and
exactly. So the same which we have configured. We have this is the same configuration which we have used in our Terraforms over here.
Yeah, and you can see now it's 0 nodes now because no runners. I mean,
no runner pods over here.
That is what I wanted.
Okay, so let's do the slide. Now we are in something. Just a minute. Yeah, let me pull here. Let's see it in action. Okay. So I have.
Do you need some drum roll?
Any questions so far? Because we are in the 3rd takeaway.
I'm excited to see. I want to see that 0 scaling. How fast it's going to scale?
You want to see it in action. Yes.
Let me just give you one catch here. There is no node right now in the system, right? So you need to expect 1 latency, somewhere around 40 to 1 minute latency, until the node is provisioned by Karpenter. This is still faster if you were going through auto-scaling group, because with auto-scaling groups, your API request goes from EKS to auto-scaling group to your EC2 instances. So there's a 1 hop. But with Karpenter, it directly goes to EC2 pool. So it is still faster to use EKS Karpenter. But Once the node pool is provisioned, and let's say in the same time your GitHub Actions execution is over, and if a new execution comes, since the node pool EC2 is already there, it will be much faster. It will be just instantaneous. So just little latency for the node provisioning. But let's go for it.
So how many minutes you mentioned?
45 to 1 minute. 45 2 minutes for the first iteration.
45 minutes.
seconds. 45
seconds. I was like 45 minutes. It's my bedtime, bro.
Okay. So what I've done is I have configured an organization, my personal organization, where I can show you all the things. Here we have a repository where we're going to run our workflows in this kind of a repository. EKS Auto Hosted Runners. Here.
Sorry, Jatin, it's a question. Please. So yes, I think you already mentioned you're going to publish a blog with all the code everyone can download. Right? Even I'm keen to download and
please. Maybe tomorrow or by next week, definitely. So
I thought in 45 minutes. Okay, just kidding.
Okay, so here we have 3 kind of GitHub workflows. So I'm gonna be showing you short sleepy metrics. Let's walk you through workflows. This is a sleepy metrics, which runs on when the
Jatin, you may want to zoom in a bit.
Yes, thank you.
Yeah, this should be good.
Okay, so in this workflow, it is triggered on when something is pushed to master, or we can use a workflow dispatch. Like I said, you need to remember your Arc runner set name. That's here. That is how it will know where to send your where this GitHub action workflow will be executed, which pod, which runner set. And here we are running 5 parallel jobs, which will be running for the total, which will be sleeping for like 60 seconds. Since it's parallel, the entire GitHub action will run for entire 1 minute. That's it. Simple. So just 1 minute and short sleepy metrics. So yeah, either it can be run through a push trigger or it can be run through a run workflow. And here we go. So let's see something in here. kubectl get kubens. Okay, kubectl get pods namespace arc runners, because here, and we can do watch. Oh, it's just that these are the same nodes, and I can just show you over here also in the second terminal. Get nodes. 5 jobs, 1 job per node I have configured. So 5 jobs, 5 nodes, and they are ready. And yeah, and how much time it took? Somewhere, let's see here.
So it deployed to one of your system node pools as well?
Because I'll tell you just one reason. That's a good question actually. Because we are using this configuration M7A spot node pool for the listener pod, for the runner pods. Okay. So it will never go to your system node pool, never ever.
Yeah. Okay. So, but you mentioned 5 jobs, each job 1 node, right?
M7A spot.
Can you get the nodes?
Here you are, nodes.
Okay, it should be 6. 1, 2, that's 3. Why, because there should be one system. Yeah. Can you type kubectl get node claims?
Kubectl get node pool. Yeah, exactly. You're right.
Node claims.
It's a Karpenter. So 5 nodes. 1.
Oh yeah.
Node claims. Yeah, Karpenter uses something which I figured out.
Oh, sorry. Maybe some. Yeah. What is that? Okay, cool. Okay, see, yeah. Then we have one on demand. That's your system. Nice.
Exactly.
Beautiful. Within like 109 seconds.
Yeah, I mean, I just loved it. So So you see, if you run it again, now let's run it again, just because I wanted to show that latency concept.
2
Because there was
minutes is not too
system.
late. Trust me.
Sorry, what?
2 minutes. I'm more than happy with the 2 minutes.
Yeah, I mean, but now it will be 1 minute. It will be 1 minute because nodes are already here for this in the system. I just loved it. So, okay, just let's go with one more experiment which I'm gonna do after this.
I think cold starts don't leave you anywhere.
Okay, so let's go with something else also. I will show you. I talked about self-hosted runner test, right? Sorry for the typo. Yes, this is good. So this is a kind of a job which we can expect in our organizations to run, where one service is talking to Redis, for example, in your case. So what is this? Let me walk through this code. You are gonna run your normal computation workflow in a BusyBox container, saying hello world. That's it. You have configured your runner to access Redis host through this environment variable. And there's another container, which is your service container, which is running Redis inside it. So BusyBox needs to talk with Redis. Exactly. That's something we have to talk. And this is where we are using DIND. Notice the name over here. But if you have seen here, I have made a typo in my code. It's DINDD. And this is never going to work because it's never going to find that runner set. So let me just edit on this fly. On the fly, DINDD. Yes, we are good now. Good. Commit changes. Fixed. Okay, commit changes. Oh,
so we have a new version of Docker in Docker, new name, DINDD.
That's because it's on the push. We can cancel this. So, but did you see this? Because the nodes were already here, it exactly took 1 minute. Fast, very fast.
Nice. So my favorite part is like it's spin up within like seconds, even the nodes. Like
yes. That's the power of EKS Auto and Karpenter over here in the behind the scenes.
When we did the EKS Auto Mode, the demo, like we did a deep dive, Jones and myself. So we were trying to deploy different type of test workload, and we noticed like within few seconds it's ready. And even the cluster upgrades are like the node, the eviction, the pods, and everything is like very fast.
Exactly. And one more thing which I loved about EKS Auto is it's very consistent. You know, the Karpenter, whatever the Karpenter is doing behind, whoever doesn't know about Karpenter, you should be very confident that it's a very consistent performance. I'll give you a test about performance also. Let me just show you over this. Runner said DD. Actually, I didn't have to use that. We didn't have to commit it. We can have configured here. I forgot totally. But yeah, let's do it. So
that's what happened when we are very excited. Too excited.
Let's see. Let me just check what's the status of our notebook. Okay, it's spinning up again, I think. Yeah. So it is running on arc set DINDD. Containers were initialized. So let's see. It's going to take just like some minutes for that. 5 minutes actually. So I think, yeah, one good thing we can do is we can test like whether we are able to access our Redis from here. kubectl. exec kubectl. Let me just do some magics over here. Cubins. We have 5 minutes. Art runners. Kubectl get PO. So this is the Arc runner pod for running our workflow, which is running right now because we are waiting for 5 minutes. Let me do it a little fast. Kubectl exec it. Okay, let me just give you one more thing. Describe, because that's important. Describe PO. You will see there are 2 pods over here, 2x2 saves, but so like I said, this is the one which is running your busybox, and this is the one dind container which is running Docker inside Docker Redis image. And let's go to describe kubectl exec it pod container. I'm always forgetting this code. Runner bin sh. It should work. If I come in, oh, we got. Oh no, yeah, okay. So sudo apt get. I will just tell you whether this pod can access the Redis or not. Sudo apt get install netcat. Netcat is just to query some host. Okay. So if we want to see Docker PS, so our Redis is running on 6379 port. Netcat, my local host would be 127.0.0.1 and the port would be 6379. Okay, hello. Okay, Redis is answering 7.42 Redis version is so this runner pod can access your Redis. That's how. So dind, a very powerful feature. Let's go back, out, exit. Okay. So yeah, here we are with these actions. Now, do you want to see something on the performance? What if we are, because I've been talking about some concurrent jobs right from the start. I've configured a script for you guys so that we can play around something to performance. Okay, so this is my same repository where your dind, gha, and everything stuff is here. Now, what I have done is, for this short sleepy metrics, I have configured a script which continuously triggers this GitHub action for like 10 minutes and in an interval of 45 seconds, to show that concurrency, because GitHub action is taking 1 minute, but in the duration of 15 seconds, there will be concurrent jobs, just to simulate a everyday situation in a large organization. Okay, so ls node script.chase. Let's see the action, how consistent the performance is, or okay, what I've done. Okay. I remember. There's one thing which we need to do. Just a minute. Because we have edited from the git pull origin.
All in the same repo. So you edited the browser, right? Yeah.
Yes, that is why. That'll happen. I think just to check. Why those changes are not coming, which we did. Git pull origin. Is it like master? Why the changes are not coming? Just a minute. Because we have changed dind and the didd we have added, but somehow the changes are not coming up. The commit is not coming. Is it like git fetch? All the comments
should get it. I get it.
But still, it's not.
Because you're trying to push something. I mean, if you can see, one changer to pull first.
let me just add one thing. We can have a fix over here. Git push. Where's git push? Git push. Because this. Where's git push? Dirty hack.
Yeah. Kids, don't try this in production.
Yeah. Okay, that's working. Okay. So now you are gonna see something exciting. Yes.
Cute.
Okay. Let's see some things for now. Okay. In the meanwhile, I will talk about another interesting thing which I observed. Okay.
Is it only you, as everyone's desktop is more with the screenshots? I thought it's only me.
Oh my god, this blog thing. We as a community builder, oh my god. Oh my god.
It's not only me or you then. I can die peacefully.
Okay. So, meanwhile, the performance testing is happening. I will tell you something about when I did the same thing with GitHub organization. Was very inconsistent. So, I was running this GitHub organizations in my company's organization, so I cannot do the demo over there because of the PIIs. But when I was running the same sort of sleepy metrics on GitHub organization on 8 core runners, there was a very interesting thing which happened. You see on the right hand side, the time, just look at the time. Sometimes it takes 2 minutes 23. Sometimes it takes 1 minute 42. Sometimes it takes 1 minute 39. No consistency on the time limits. And you need to know that GitHub large hosted runners, which have the charge of 0.032 in case of 8 cores, charges per minute. This is a very simple GitHub action, but imagine if there's a very big GitHub actions, what kind of effect you will have on your cost with this variable performances. Sometimes it's 2 minutes. I have seen 2 minutes also. And sometimes it's 1 minute. So 2 minutes comes here, and you see, there's no consistency in GitHub organization. It's because of the concurrency. We are using actually Teams, GitHub Teams plan. Still, there's no consistency over here. That's the thing which is coming with this. Okay, let's see how consistent we have in our runner set on EKS Karpenter. So meanwhile, do you have any questions? Because it might take just 1 to 2 minutes.
Is it always?
Oh, cool. Sorry, John.
I was just asking, is it always inconsistent, or is it because of one? Or...
When I did a sort of same testing from, yes, just a minute, 4 hours ago. Yeah, from here, if we can show, it's updating everything. So when I did testing, see the same script, 1 minute 8 seconds, 1 minute 8 seconds, 7, 7, 7, 7. The only first time the node provisioning would have just taken 1 minute 22. Otherwise, it's damn consistent over here. It's like 1 minute 7 and 8 seconds all throughout your executions.
Yeah, 1 second is, I mean, fine, but a minute difference is a lot.
Minute difference is in what context? In what context minute difference?
So you were showing about 2 minutes. One of the runs took 2 minutes. One of them took
on GitHub organization side. Yes. It is very inconsistent for me. In my experience, same scripts, same timing, same configuration, same jobs. Everything is same there. That's true. It doesn't work. Something.
So you mentioned it's per minute they're charging, right? So if you're running like 1,000 jobs, that charge is for like.
I actually happen to do I happen to pull up your 0.032 per minute rates for x64. There is ARM6.
Have you done any like in-depth kind of like running this in EK, like going through the AWS billing and check the difference for a certain period? I know it's not an easy
I
job
mean,
to like
I
compare.
could
Like,
have,
it's too much of data.
yes, too much of data, but I've tried to do a very simple cost calculation, which is coming next here. I have done a sort of comparison. Yes, it might be not very 100% accurate, but we can just go. We can have a consensus. It's enough to have a consensus that something is coming up. The end game would be good. So yeah, and I was also talking about something. Meanwhile, the runners are running. There was this limits on the concurrency. So GitHub hosted runners have limitations over here. Only 1,000 jobs on a scale of very big organization enterprise. I don't know how many times we have to ask this customer's support plan. I just think total concurrent jobs on a large hosted runner is just 1,000, and the documentation doesn't do justice. Whether it's 1 day, 1 hour, 1 month, no information over here. That's how it is. Yeah. Okay, so we should see something. See the consistency. 1 minute 7, 1 minute 7, 1 minute 8. That's why I love this EKS Auto with this kind of a solution. Spot. Okay, so do you want to wait or let's go ahead? Jones, do you have any question?
So far, good.
So far good?
Yeah.
So far,
Okay.
good.
Okay. So let's talk about the last part of cost comparisons. So let me just set up the context over here. Cost comparison we are doing between self-hosted runners, M7A.2x large instance versus 8 core vCPUs, large hosted GitHub vCPUs runners. Our instances on AWS side are Spot instances, which has a cost of just a minute. M7A double extra large. Yes. So this is a very amazing website. I just love this website, for my EC2 some comparisons. So we are paying around 0.1830 for Spot per hour. Per minute charges goes to 0.030. GitHub was costing us 0.032. So GitHub Actions are very expensive. Here we have 0.032 and here we have 0.030. But we are using EKS Auto, which has an EKS cluster cost as well as EKS Auto node management cost. So this is what I've tried to do a cost comparison. Let's see how it happens. So I've come up with GitHub. I had a lot of conversations with this ChatGPT in the reasoning mode, which I've fed the parameters like there's a 1 minute happening per job. 12. This script is running for 10-minute cycle for me. On a 10-minute, on an average, there was 12 jobs, both for GitHub organizations side as well as AWS side. So we did a simple calculation like 12 nodes are running, 1 job per node. So 12 jobs, 12 nodes into 1 minute, somewhere taking around 12 node minutes. If we divide it, we have it's just a one parameter called 6 cycles, like how many cycles will happen, such cycles in 1 hour. So there are 6 cycles, 12 jobs, 72 node minutes it will take somewhere for us. Now, if we convert this nodes to into how many hours per day, it's costing us right now 1.2 hours per day. Okay, this is sort of a job specifications, GitHub jobs. Now, for the node prices, Spot instance is costing 0.030 per minute, like I showed you over here, 0.030. Total Spot cost per day for 72 minutes, which we have calculated above, 0.216. Monthly cost $6. So on an EC2 instance, Spot, just $6. Now there are some additional charges of EKS. Auto charge for this particular instance, I have calculated that. Oh, okay. So EC. Oh, just a minute. Yes. M7 2x. Oh, no. 2x.
Oh, that's correct, right? Yeah.
Yep. Okay. Oh yeah, it's correct. Just a minute.
So actually, it's plus that amount, right? Which means EKS Auto Mode. So the generic number plus this charge on top of that charge. That's the combination.
Right. So yes, 0. Just 1 minute per hour. It was taking this per hour. I'm not seeing the figure. That's why I just got confused over here. EC2 spot. If that's the case, then I don't know.
Are you sure the region is correct, right?
Region is correct because I saw some price difference. Because I saw the price 5778. Maybe I have given one different 5564. Can you guys see something 5564? No.
Nope.
Okay, so maybe I have done one calculation mistake over here. Oh, now the things will change. Okay.
We should have something about the demo, right? Something should go wrong.
Right. Yeah.
This is the one. Yes. Oh, good.
So let's assume if the cost was 5564, which is way higher than the above cost right now.
Yeah.
Okay. We can still have a consensus over here also, and we can still work around. So even if that happens, for how many? 12 jobs, we are the EKS cluster is costing the total cost for EKS solution is costing $98. With that cost, GitHub is gonna cost us $103. Same costings, but just GitHub has like 6 cycles, 0.032. Same costing, same minutes, 3240 minutes, 104 cost. But now 98 is still lower in the actual cost if we compare. Now what I did something amazing. I said, let's increase the scale from 12 jobs. Why not go to 100 jobs per hour? You see, there is a lot of change now. From 12 jobs to 100 jobs per hour. Now you will see the cost is again way higher than the actual cost, but it goes to the EKS final cost comes to $108 with the same calculation, and the GitHub cost comes to $144.
Let's change.
It's change. Scale. As you're scaling up your processes, which happens for a large enterprise, it changes. Now let's go to another kind of a situation, more scaling, 200 jobs for 2 hours. Or in a month, you have 15950 minutes. This was the number which I took from my GitHub organization, company organization, which we are running on an average, small scale organizations. If we calculate the entire cost, 219, $576. Just see the difference, 219 and 576.
Oh, let's keep doubling.
Yes.
I have a question. Maybe, so this cost calculated only for the control plane charges, but the node or like the infrastructure, like net gateways?
I haven't calculated net gateway.
Okay.
Just the net gateway, because this solution, because we are not using S3, EBS volume, nothing. We are using ephemeral storage of the instance. So other than EKS Auto, EC2 instances, the another component is coming with the VPC components, which is not going to cost so much, which I've also seen in some blogs.
Okay, cool.
These are the 3 components which is going to cost us, other than nothing. Even if we calculate that, still the difference is getting bigger. I really don't care if we add up $100 for NAT gateway also, it's still I'm going to be happy, you know. And if the percentage difference which are coming is somewhere around 57, let's go to more realistic numbers, 30 to 40%, I can say. You know, we can get 50% if, you know, more better data. But yes, that's the data which we are coming with. And I also did 200 jobs per hour from 12 to 200. same calculations, nothing changed. $145 for EKS infrastructure cost, and GitHub runners cost $288. So it's still a 50% upside for GitHub organization runners. Now I might get just wrong. I will just try doing something with here. Okay. Let's just say there is a change in one parameter. The EKS Auto Node charges, which I don't just see what kind of charge definition it's seeing for EKS. Just 1 minute.
I just put a comment. The link you're using, the vantage.sh.
Yeah.
For compare the prices. So if anyone interested can go and check the link.
EKS Auto Node per minute rate is not $0.0564. Just
5564. Yeah.
5564. 5564. It's 0.1809. 0.1809. Please calculate again. Oh, I mean for 200 jobs per hour. Let's see if it can do something. We'll do one thing. If everything's same, all the other calculations, just and then compare EKS versus GitHub solution, which we have been doing earlier. It's like a kid. I should have done reasoning. No, it's not working as which we were working. Maybe because it's not working correct with this price, I think. Remember the previous calculations?
Yeah, this is exactly where Gen AI gets on steroids.
Yeah, the earlier so the context, it gets lost.
Well, at least with an assumed cost,
Yeah,
you still see that. Yeah.
It's still, I think, 50% better for us.
And given that was already a higher cost, it's going to be much cheaper.
I think now it's working. Now it lost everything. It has lost entire context. My God, just in 1 hour.
Our jobs are still safe.
Everything. Okay. Cool. Okay, so what is your call? So that was one of the things. Now let's just go back to our GitHub Actions. Oh, I love this. I love the results. It's
nice.
It's consistent as well.
Even look at the seconds: 8 seconds, 8 seconds, 8 seconds, 8 seconds, 7 seconds, 8 seconds.
Yeah,
and what kind of configuration did I need to do in this code? I had to do like literally nothing. It's just the normal EKS code, just a custom node pool which I have to set, and an Arc controller. Nothing. It's just the charts are already given. Just go to your dind, configure just little things. Of course, you need to know just one thing. This kind of a configuration, node pool, selectors. That's it. And this is also given in EKS documentation. So what I'm trying to get is, in terms of setting up this solution, making your CI/CD pipeline faster, making your CI/CD faster, having a better control, consistent performance, have a better cost to performance ratio. EKS Auto is giving you the entire solution. And if you combine with ISC, oh my god, that's like a match made in heaven with Terraform and any kind of an ISC.
So you're saying your ice cream, you're putting a cherry top of that with EKS Auto Mode, because you can scale from zero to any number you want within few seconds.
Right.
Not even minutes, I would say a few seconds now. Like we saw, right? It took like a couple of seconds to spin up, and you can customize your node claims, node classes, whatever you want. Like
Exactly.
it depends on your workload type, and especially spot instances. And I was thinking, even the single node which the controllers are running, if you're really keen about the cost, maybe you can run on a very small node to
Right.
run only the controllers, and you can observe it, how much performance it's utilizing. And for the runners, yeah, it's OpenSea.
I mean, the reason I love this solution, I was not expecting. I have never done this solution. First of all, it was just for this podcast. I was doing this on AKS. I was very amazed, because when I was doing with AKS, I had to do a lot of things, like same VM scale set in Azure Lingo. Oh my god, it was not as fast as this. Performance even there wasn't consistent because there was scale set, not the Karpenter. So with just some EKS knowledge, some configurations around Arc and your node tools, you are making developers' life so easy, because your CI/CD becomes a blocker. Eventually, your CI/CD becomes a blocker, and that's what I've been doing lately in my organization as well. It's a blocker for a lot of developers. I think when you're getting such kind of performance and cost, I think it's worth to adopt this kind of a solution.
Yeah, if it improves developer productivity, all yes.
Exactly. Of course.
It's good for platform teams too, right? Like you're running a single cluster, and you can use pod identity or OIDC to access other cross accounts and deploy your if you have other multiple EKS clusters and do deployments. Yeah.
Right. Also, this solution would be even better for the organization which are already using EKS, because you have your EKS, you just have to use little more resources and give it to your just add the solution to your existing EKS. Then it will be actually much more cost effective, because ideally you will be paying for the bigger application side, not for the solution. That's what I think.
Cool. And we are looking forward for your blog. And trust me, I don't know how you're going to explain all this amazing thing on a one single blog.
Yeah.
I would say write a series and add those things. What do you think about that, Jones? Right? Like, imagine all this knowledge putting into a blog.
It's going to be one overwhelming blog.
Yes.
Maybe split it down into different segments or videos or whatnot.
Let's try. I'll try how it goes. But yeah, that's it. So
thank you.
Yeah, how are we doing with the time? I think we are a little over time.
Little over, but yeah, this is amazing.
This is amazing.
Thank you. Do we have any?
While you're explaining, I was thinking different scenarios where we can use it. Like, maybe we can talk in the future episodes, right?
Right.
Some cross-account functionalities or some different things, right? Like try. And yes, and why not?
Okay, cool. I think I would be very interested to extend this solution more complex scenarios. Do we have any questions from the audience, Jones?
I think we're good. Yeah, the question was, how do we get your GitHub access? GitHub code access. So blog is what everyone.
So can we can imagine, like, you're the job and you want to run you're creating your blog using a runner and deploying the EKS cluster. EKS Auto Mode cluster and get it done faster. Why not, right?
Like that, AWS New Zealand, UG, same. I'm crossing across. I'll try.
Sorry. Okay.
We
You know what's going on the behind? That is fun.
Okay.
No, what happened, so this platform, right? We have all these comments. There's option that we can show here, like John, he's thanking you for amazing content, and John is always there and he's sharing a lot of feedback and supporting when we stuck on some demos also, like he was helping. So he's from Wellington. I know John personally.
Okay.
He's always there for attendees, and he's part of the community day organization team as well.
Okay. Thank you, John, for being there for this amazing Zacs Show episodes. Thank you.
So what happened actually? I was clicking the show button, and I think Zach also trying
doing it at the same time.
And it's popping up.
Oh.
Yeah, concurrent jobs in action.
Yes.
At least somewhere concurrency is not good.
Yeah. Cool. Then, thank you, Jatin, and this is another episode, right? Like John's mentioned, 3 different time zones. It's almost midnight for me, and what's the time there? I don't know in Tokyo. What's the time?
7 p.m. We are 10 minutes behind to 7.
Okay, I'm 10 minutes behind to 11. Yeah.
Yeah, and I just want to say thank you guys for giving this chance to come up, and giving me this opportunity to actually find out the solution for our audience. Trust me when I say that I haven't tried this, and I didn't try on EK's side. It was from scratch, and I just want to tell you last words in Japanese when everybody does a good job. In the end of the day, all employees every day say one thing. It has a very great meaning. We say "Otsukare-sama desu."
Otsukare-sama desu.
Otsukare-sama desu. So, Otsukare-sama desu.
Otsukare-sama desu.
Yes. So it just simply means thank you for your hard work today.
Oh wow!
It's very beautiful, and it just gives a lot of happiness. So Otsukare-sama desu, minasan.
What's minasan?
Otsukare-sama desu, minasan.
Minasan.
Yeah, minasan, everyone. Otsukare, thank you for your hard work today.
Wow. What's only thank you?
Thank you. In a very formal setting, it's arigato gozaimasu.
Okay, too many Japanese words.
Okay. Arigato gozaimasu.
Arigato gozaimasu.
Yes, in a very formal settings, which is used with customers, managers. But if we guys are here, arigato.
Okay.
Arigato.
Arigato, Jatin.
Yeah.
For this amazing session.
Cool. Thank you, guys. So I will just take a leave, and thank you.
Thank you.
Looking forward for another great sessions. Cool.
Look forward for another session as well, and
Okay.
stay tuned for the upcoming podcast. Until then,
Bye.
see you.
Bye bye.